So the backstory to the Hex motor is actually fairly simple. Industry demand. We have two sections that make up a downhole motor. One is the power section and one is the bottom end or transmission. Two companies are responsible for those, two different groups. One group usually designs and produces the power section, and then various other groups produce the bottom end. And they're always getting married together. So you have this ebb and flow where power sections will be stronger, then bottom ends are stronger. And starting about 5 years ago, we entered into an area where power sections had significantly increased their output in terms of horsepower or torque, and bottom ends were trying to keep up. What I have here is just a simple demonstration on what we would call an industry standard drive for a bottom end. It uses balls to transfer to an outer housing, and as this piece turns, it also can articulate. It works great. Balls are tight, and it transfers torque from a turning to a movement of a CV joint and then to the bit. Works great until the horsepower from the power section gets too great. And these little balls, the pockets these balls sit in, tend to stretch and become elongated. When that happens, you do it enough times, and eventually the portion that fits over here will have a catastrophic failure, and it will actually break in two. So after some failures over a period of time, we had some clients reach out to us and say, is there any way that you can design a bottom end that would be more capable of handling the output torque of the power sections that are out today? As any group of engineers, there's a challenge at hand. We start to think about how could we drive that. And what I have in my hands today are something that most of us have used. It might be a bigger scale, but if you put some furniture together from a particular Swedish store, you'll know what I'm talking about. So the premise is, applying torque. And this can be done many ways if you're acting in a straight line. The problem we have with a motor is that we're acting not in a concentric line. We're turning about a non-concentric point. But it actually works fairly well if you take the ball end of this and I want to start to apply torque. So that's literally where the concept for the Hex came from, was the ball end of an Allen key. And it's fairly easy to see just with the eye how much better a flat surface like this can transmit torque versus a round ball. So we have a series of these keys that we lay on the outside of the drive, and they go in an adapter housing that eventually drives down to the bit. So there's two things driving this design. Number one was the higher horsepower coming out of the power sections, but also longevity and reliability. When clients come to us, the laterals are getting longer all the time. We're spending more time in the hole. Number one, we'd like to drill them faster, but more importantly, it needs to last the duration of the lateral. So this design, it distributes the forces. It also handles vibration. It's just more forgiving with the flat surfaces than the ball drive is. So we've been able to produce a motor that is more reliable in the long run and actually utilizes the increased horsepower that the new power sections are putting out. So the clients can drill faster, the laterals are longer, they're doing it in the same amount of time as the shorter laterals, and they're not needing to make wasted trips because of motor failures. We developed many different types of tools. This one was probably the one that gave me the most angst because we started something from scratch. Often when you see the development of a tool, it's either the evolution of something that someone's already started, changes in material, maybe changes in dimensional aspect of the tool. This was a concept that came out of a hex key. And this, whenever you're designing or developing a concept from scratch, it always gives the team more angst because you can't always predict the problems. And after several hundred runs, we know we're making a difference to the industry. It's really a chance to give kudos to a development team that can see something from a raw design to a finished product that's making an impact in the industry.